Imagine waking up tomorrow to just, a perfectly ordinary morning. You're pouring your coffee, you look out the window, and suddenly, with absolutely zero warning, no countdowns, no sirens, the Earth just stops spinning. The whole planet literally halts in its tracks. What would actually happen to us? Well, in this explainer, we're going to dive right into the immediate physics, the wild long-term planetary changes, and how humanity might somehow adapt to a completely unrecognizable version of our world.
Section 1, the sudden global standstill. When the planet breaks.
So, to really wrap our heads around the pure chaos of a sudden stop, we first have to respect the absolutely incredible kinetic energy we're talking about pausing here. What if it stopped today? I mean, think about the sheer colossal mass of the Earth for a second. The continents, the mountain ranges, the incredibly deep ocean trenches. We are talking about slamming the brakes on an entire planetary body all in a single instant. It's a completely mind-boggling thought experiment. But to truly grasp the scale of the catastrophe, we really need to look at the numbers. Right now, as you're sitting there watching this, Earth is actually spinning incredibly fast. Down at the equator, the surface of our planet is traveling at roughly 1,040 miles per hour. Just to put that into perspective, that is faster than a commercial passenger jet. But of course, we don't feel it. We don't feel like we're out here breaking the sound barrier because literally everything around us, the ground you walk on, the trees, the atmosphere itself, is moving right along with us at that exact same speed. Which brings us to Section 2, Momentum and Immediate Catastrophe, the Unstoppable Force. So what actually happens when that perfectly synchronized movement is violently interrupted? Well, it all comes down to momentum, the quantity of motion of a moving body. Think of it like this. If you're in a car traveling at 60 miles per hour and you suddenly slam on the brakes, your body wants to keep moving forward at 60 miles per hour, right? That is exactly why we wear seatbelts. Now, imagine the Earth is that car, but it's traveling at over 1,000 miles per hour. If the solid ground stops instantly, the atmosphere and the oceans, which remember are not bolted down to the bedrock, still retain all of their original momentum. They are going to just keep moving forward at 1,040 miles per hour. The result of that? A horrific 1-2 punch. First up, because the atmosphere kept moving, extreme global winds. We are talking essentially supersonic storms would sweep across the continents with just unbelievable destructive force. And second, the oceans. These massive bodies of water would also just keep hurtling forward. This creates catastrophic coastal flooding, as unimaginable, towering waves crash miles and miles inland. Entire coastlines all around the world would be dramatically reshaped in a matter of hours. The map as we know it would literally be erased. Section 3, a radically transformed planet, Earth's new geography. Okay, so if we somehow look beyond that initial devastating shockwave, the biggest long-term change alters something we experience every single day. A single day would roughly equal 1 year. Think about that. If the Earth stopped rotating on its axis but kept up its orbit around the sun, our entire concept of a 24-hour day just vanishes. One full cycle, from a sunrise to the next sunset, would stretch out over approximately 365 days. And as you can probably guess, this leads to a terrifying climate reality. On one side of the planet, you'd be stuck with extremely long periods, basically half a year, of intense, continuous, glowing sunlight. The temperatures there would absolutely skyrocket. Meanwhile, on the totally opposite side, you're dealing with months of freezing, absolute darkness. The landscape would basically turn into a desolate sheet of ice. We're talking about extreme temperature changes that would drastically alter Earth's entire climate system, making almost the entire surface completely uninhabitable. But wait, the geography would shift in another incredibly surprising way over time. Right now, Earth's rotation creates this centrifugal force that pulls water toward the center, giving the planet a slight outward bulge of oceans around the equator. Well, if the Earth stops spinning, that outward force is just gone. Without that rotational bulge, the Earth's oceans would slowly redistribute, migrating away from the equator. The waters would shift massively toward the northern and southern polar regions, which would completely redraw the boundaries of land and sea. We'd very likely be left with a giant, continuous megacontinent wrapping all the way around the equator, with two totally isolated oceans at the north and south poles. Moving on to Section 4, the magnetic field mystery. Does our shield survive? Now, this is an absolutely vital question for the survival of any remaining life on the planet. Does the magnetic shield die? Right now, we are surrounded by these invisible, glowing magnetic field lines that protect us by deflecting deadly solar particles coming off the sun. If the planet suddenly stops spinning, does that invisible shield just shut off? Does it leave whatever's left on the surface exposed to lethal solar radiation? Well, the answer is super fascinating, and honestly, it's a rare bit of good news here. Earth's magnetic field is actually mainly generated by movements and churning deep inside its molten outer core. That inner dynamo operates largely independently from the rotation of the solid surface crust we live on. So the key takeaway is that stopping the surface rotation wouldn't automatically switch Earth's magnetic field off. The core could just keep on churning, meaning our protective shield might actually survive the standstill.
Section 5. Surviving into year 3026. Humanity's adaptation.
Let's just say the magnetic field holds up, and a fraction of humanity manages to survive by retreating deep into underground scientific shelters. Fast forward a millennium. The ruined world above is still locked in its massive, one-year-long day-night cycle. But humanity? We've learned to adapt using highly advanced technology and completely artificial environments. Imagine opening your eyes from a long sleep to hear a floating AI assistant say, "Good morning. Today is July 18, 3026. What does human life even look like at that point?
Well, within milliseconds of waking up, you're looking at transparent smart walls displaying holographic news, with perfectly controlled weather keeping your habitat comfortable. Within minutes, you look out a window to see a totally impossible skyline. We're talking flying cars darting between massive floating buildings, completely detached from the ruined surface down below. And within hours, as you head out for the day, you might find yourself walking across an epic sky bridge. You'd share the path with futuristic humanoid robots and autonomous vehicles, totally surrounded by lush vertical green forests clinging to skyscrapers. All of it entirely powered by advanced, clean energy systems. Civilization wouldn't have just survived the catastrophe. We would have engineered a breathtaking, cyber-futuristic world to conquer it.
Now, obviously, a scenario where the Earth just stops spinning sounds like pure science fiction, but this whole thought experiment serves a really beautiful purpose. It highlights the quiet miracles we totally take for granted. Every ordinary day exists because our planet is constantly moving. We enjoy tempered climates, predictable seasons, 24-hour days, and stable coastlines, and it is all because of that continuous, silent spin. So, the next time you step outside to watch a simple sunrise or a beautiful sunset, will you remember the impossible speed at which you're actually traveling? You are literally standing on a massive spaceship made of rock and water, hurtling through the cosmos and spinning at over 1,000 miles per hour, all perfectly balanced just to keep you alive. Thank you so much for joining me for this explainer. Keep wondering, keep learning, and I'll catch you on the next one.